present your work.
Yes.
Aamir Shakoor is from Department of Agriculture and Engineering, Gaudiya Zakariya University. He is going to present his work determining canal water deficit in Lower Chenab system using remote sensing technique. So please start your presentation.
Thank you, madam. Please wait for a while. Are you looking for my presentation?
Yes, we can see.
Thank you. Bismillah ar-Rahman ar-Rahim. Dear Director, Center of Excellence, Water Resources Engineering, international researchers, faculty members, and students, Assalamu alaikum. First of all, I want to say thanks to the organizing committee for providing me this opportunity to share my research work on managing canal water deficit in Lower Chenab Canal system using remote sensing technique. As we know, the survival of our agriculture and livestock is very much rely on freshwater resources, and some of future scenarios shows that the less water will be available for successful crop production in the future due to the lacking of the canal water resources. Agriculture is the largest user of the fresh water of Pakistan, and as we know, the mismanagement of water resources is the one of the main reasons behind the major water resources issues in the Pakistan. In an irrigated area, the timely and effective measurement of groundwater requirement will assist in the managing canal water. So based on this, the remote sensing technique is an effective tool and give opportunity for irrigation management and water allocation for surface water. The main objective of my research were to determine and validate the crop coefficient and reference evapotranspiration by using NDVI from modest TSP dataset collected from the RStudio software to estimate the cropping area and irrigation requirement of the LCC canal system and to determine the canal water deficit and to develop guidelines for water resources management in the area. Here is the graphical location of my research area LCC in almost in the center of the Punjab. It contains 1.25 million hectares of area. The major crops selected for this research were sugarcane, cotton, maize, and wheat and sugarcane. There are 6 major canals in the study area: Upper Jung Canal, Lower Jung Canal, Rakh Branch, Upper Gugera Branch, Lower Gugera Branch, and Burala Branch. Here is the schematic showing of the methodology. It contains the data collection and other parameters. The data collected were from the remote sensing and the climatic data, discharge, and crop for the years 2018 to 2020. The modest dataset was used in research in which the two satellite data, Terra and Aqua, were used in this research. The irrigation requirement of the crops were determined using the total sum of the crop area multiply with the crop water requirement of that particular crop. The final result of this research, before going toward the research, the value of evapotranspiration calculated from the remote sensing data set were compared with the evapotranspiration result of the crop model, and it was found that the R square of that result is about zero point 0.9. It means that the data collected from the remote sensing data sets are highly effective. The cropping area and built up area for the study area was divided into two parts, LCC East and LCC West. Here is the showing of the cropping and build up area of the LCC East. Now, this slide shows the cropping and built up area of LCC West, in which the estimated and non-crop the kharif area is 0.4 million hectare, while the non-cropping area was 0.079 million hectares. This slide shows the crop water requirements in the LCC East. We can see that the crop water requirement in the month of March to September has the higher values as compared to the October to Feb. Similarly, with the LCC West, the higher crop water requirement months were March to September. Here is the supply and demand comparison in the LCC East. You can see that in the month of November and December, we have higher supply than the demand. Similarly, for the next year, the supply was higher than the demand. Generally, it is assumed that we are deficit in canal water, but it is shown in the figure that we have extra water than the need in the crop water requirement in the canal command area for that particular canal. So it should be safe for future use. For LCC West, you can see for the month of January, for the month of January, for both years in 2019 and 2020, the supply was zero and the demand was very high. Here is the seasonal comparison of LCC East and West. Uh, we can see that the supply is less as compared to the demand. The difference is higher in the LCC West for Kharif 2019 and 2018. Similarly, with the LCC West for Rabi in 2019 and 20. The seasonal percent deficit is shown in these slides that in Kharif, the LCC East was 17% deficit, while the West was 55% deficit. The maximum deficit in the LCC West was about 60%, and the maximum deficit in the LCC East was 21%. You can say that the west part of the study area is under deficit as compared to the east side. This is the total by combining the LCC East and West. The difference of demand and supply is about 46%. You can say that about 50% of the crop water requirement is not fulfilling by the canal. So the based on these results, we can conclude that the remote sensing data set can be used for determining the evapotranspiration, and the average seasonal water deficit for Kharif and Rabi in the LCC was 37 to and 45 respectively for the years 2018 and 20. Based on this, the guidelines developed that the adaptation of high efficient irrigation system should be adopted, and the capacity of LCC West Canal is less, so to share of it should be increased, such as to cope the deficit in the irrigation of the field. To cope the deficit, farmers should be farm mechanization practices should be used to minimize demand increasing in the field capacity. It is recommended to use modest product uh, in any study area, so that the timely management of the groundwater uh, of the water sources in the study area. The data of the modest modest TSP data set, as well as discharge, should be for more years in order to analyze more efficient way in any study area. Thank you very much.
Thank you very much.